Hello everybody, my name is Zubin Chaudhry. I am a PhD student at the University of Central Florida. The co-authors of this paper are Dr. Gerd Bruder and Dr. Greg Welch, and I'm going to be presenting our paper titled Visual Facial Enhancements Can Significantly Improve Speech Perception in the Presence of Noise. So human speech perception is multimodal by nature. To understand spoken language, we listen to speech, but we also read lips. Um, Reading lips or lip reading is our way to visually interpret lip movements and associate that with speech. There are situations when our overall speech perception is poor, such as noisy environments or if you're hard of hearing. And a lot of focus, a lot of research has been going on improving the audio signal to help us hear better, such as signal processing techniques like noise cancellation, voice isolation, or even physical apparatus like hearing aids. But there's another line of research, and they found out that in situations when the audio signal is poor, humans actually tend to rely on lip movements a lot more. So, to actually study the visual modality of speech perception, researchers in the past have used 2D displays to test their hypotheses, and it mainly constituted of videos of other people speaking. And some key factors that they identified were the display resolution on these displays were very important for speech perception. The image size was very important, and the color contrast was very important. All of them very important to discern our lip movements and help us in our speech perception. As we were studying this, as we were studying their papers, we saw an opportunity to actually use this information um, in a real-time face-to-face interaction using mixed reality technology. So we wanted to test whether there is potential, it is worth actually looking into changing the visuals to improve our speech perception. So quite literally, we are testing two visual manipulations, um, digitally scaling heads, such as a Snapchat filter, and also digitally adding lipstick. So that led us to our research questions. Firstly, how does increasing head size and adding lipstick improve, or what effect does it have on speech perception? And also, since we are using a display technology, we wanted to know what does the display resolution have on speech perception as well. So we ran a partial factorial within subjects design experiment with 21 participants. Participants used the Quest 2, they wore noise cancellation headphones, and they put in a whisper room to maintain a quiet environment. And they performed a speech reception threshold in noise test. This is a test to objectively measure a person's speech perception. This particular one is a form of a test that audiologists use to find out if you need hearing aids or not. So specifically, we get a signal to noise ratio at which a person can understand speech 50% of the time. So an example is like this. So participants hear a lot of noise, and in the midst of that noise, there is a three-digit number. They attempt to repeat this triplet back on the keypad, and every time they're correct, we make it harder. We actually make the speech softer by 2 decibels, and every time they're wrong, we make it easier by increasing the decibel value by 2. We do this 25 times and we average the last 10 signal to noise ratios to get their speech perception scores. We additionally ask them how confident they are with their response after every trial. So this is the audio only condition, there is no visuals. We tested this scenario again with a virtual human. This virtual human is from the Rocketbox Avatar library, and what we wanted was realistic facial features and lip movements that that we would get this information, this visual information in the real world. So to do this, we recorded a person speaking these numbers and then projecting it onto an avatar's face, um, and this is how that looked. So we wanted to, the goal of this experiment is to test the facial enhancements. So um, we did this another condition with with the facial enhancements, as you can see. The two enhancements we focused on were scaling the heads and increasing the lip contrast, the facial contrast, the lip contrast specifically, by adding red lipstick. And this is how that looked. Um, So some of the audio stimuli that we had to create, the speech signal was detached from the audio, the video recording we took, um, and the background noise was a eight talker babble, which means there were eight people talking at the same time. We generated this by using Google's text to speech API. We generated four female, four male, and we superimposed them. And the decibel calibration was done by a sound level meter and Audacity audio software. And overall, this was our design: two display resolutions, two facial enhancements, with and without, and a control condition, which was the audio, which was audio only. So our results look like this. We have two bar charts. The first one is the SRT scores. Um, so on the y-axis, we have signal to noise ratios, and the lower the signal to noise ratios, it means better speech perception. So low score is good. And the second bar graph is the self-assessed confidence score that we asked after every trial. So let's focus on our first research question, which was, what does these facial enhancements have on our speech perception? First of all, we saw significant improvement in user speech perception. Um, so as we go to the right, we see a lower score, and all of them were significant as well. Secondly, they could compensate for lower resolution displays. So if we see low AVE and high AV, we see these two bar charts, we see they're very close. The left one is with the enhancements but low resolution. The right one is no enhancement with high resolution. So there was a good compensation going on there. And we subjectively asked participants after the experiment which one, if you had a choice between head scaling and facial contrast, which one would do you think would be more beneficial in terms of speech perception? And they preferred head scaling over facial contrast. In terms of confidence, we see a gradual rise, um, and also we see that the facial enhancements gave more confidence to participants than the resolution change. Our research question two was, what are the effects of display resolution? And as expected, we see a clear benefit of higher display resolution on speech perception and confidence as well. Um, the main reason has to be the main reason is there's more pixels to face or mouth ratio, and that just helps in interpreting the movements. So overall conclusion is display resolution is very important, especially when we have something on displays or something visually. Facial enhancement techniques are potentially could be very important to improve speech perception in the future. It can compensate for low resolution displays. And amongst the facial enhancement that we tested, head scaling was preferred over facial contrast. These are all the references that I used. I'd like to say thanks to everyone in our lab who helped me out. And if you have any questions, please email me at zoopandchaudhry@ucf.edu, and I will be around at the conference in Sydney as well. Thank you.